So, what is the smallest possible sum of squares of two numbers if their product is -16? So, let's have x plus y represent the two numbers. Now we need to find a way to define the sum of the squares of the two numbers. So s here is going to represent the sum of the squares, which would equal x squared plus y squared. So this is what we want to minimize. We want to minimize s, and right now it is expressed as a function of x and y. We don't know how to minimize with two variables, so we have to get it in terms of only one. Their product is -16, so x times y is going to equal -16. If we wanted to find s only in terms of x, we could figure out what y is in terms of x and then substitute. So let's do that over here. If we divide both sides by x, we get y equals -16 over x. So let's replace our y in this expression with -16 over x. So then we would get our sum of squares as a function of x is going to be equal to x squared plus y squared. Y is -16 over x, and then that's what we will now square. So this is equal to x squared plus 256 over x squared, or we could write that as 256x to the -2 power. That is the sum of our squares that we now want to minimize. So to minimize this, we would want to look at the critical points of this, which is where the derivative is either 0 or undefined, and see whether those critical points are possibly a minimum or a maximum point. They don't have to be, but those are the ones that if we have a minimum or a maximum point, they're going to be one of the critical points. So let's take the derivative. The derivative s prime of x with respect to x is going to be equal to 2x times -2 times 2x plus 256 times -2. So that's minus 512x to the -3 power. But now this is going to be undefined when x is equal to 0. But if x is equal to 0, then y is undefined. So this whole thing breaks down. This isn't a useful critical point, x equals 0. So now we have to look for another one. Well, it's defined everywhere else. So let's think about where the derivative is equal to 0. So when does this thing equal 0? So when does 2x minus 512x to the -3 equal 0? Well, we can add 512x to the -3 to both sides. So you get 2x is equal to 512x to the -3rd power. We can multiply both sides times x to the 3rd power. So all the x's go away on the right hand side. So you get 2x to the 4th is equal to 512. We could divide both sides by 2, and you get x to the 4th power is equal to 256. And so, what's the 4th root of 256? Well, we could take the square root of both sides just to help us here. So let's see. So it's going to be x squared is going to be to 256 is 16 squared. So this is 16. This is going to be x squared is equal to 16, or x is equal to 4. Now, that's our only critical point we have, so that's probably the x value that minimizes our sum of squares right over here. Let's make sure it's a minimum value. And to do that, we can just do our second derivative test. So let's figure it out. Let's take the second derivative s prime of x, and figure out if we are concave upwards or downwards when x is equal to 4. So s prime of x is going to be equal to 2, and then we're going to have -3 times -512. So I'll just write that as plus 3 times 512. That's going to be 1536. So 3 times 500 is 1500. 3 times 12 is 36. X to the negative 4 power. And this thing right over here is actually going to be positive for any x. X to the negative 4, even if the negative x value, that's going to be positive. Everything else is positive. This thing is always positive, so we are always in a concave upward situation. Concave upwards means that our graph might look something like that. The derivative is equal to 0, so the slope is equal to 0, and it's concave upwards, so you see pretty clearly that we have minimized the function. So what is y going to be equal to? We actually don't even have to figure out what y has to be equal to in order to minimize the sum of squares. We could just put it back into this. But just for fun, we see that y would be negative 16 over x. So y would be equal to negative 4. And we could just figure out now what our sum of squares is. Our minimum sum of squares is going to be equal to 4 squared, which is 16 plus negative 4, plus negative 4 squared, plus another 16, which is going to be 32.